Hi all, this is Ashwin Muthuraman, continuing the lecture series on graphs. So now we defined what is a spanning tree. I'll just repeat it. A spanning tree is nothing but a subgraph of G which has all the vertex of G, and then it should have exactly n-1 edges such that it is a tree, means that it should not have any cycle in the graph. So now there is a cost, because if the graph is weighted then we can have a cost. Then we'll also say we'll have an algorithm for finding the minimum cost of that out of all the possible spanning trees, which spanning tree has the minimum cost. So we have an algorithm called Kruskal's algorithm. Let me go through the explanation of Kruskal's algorithm here. So first condition for Kruskal's algorithm is that given the edge set, considering this graph, given the edge set, it should be sorted prior to the algorithm. So either we sort it or they give it in the sorted way. This is the assumption that we are starting with. The first step is to sort the edges set to be in the weighted order with the lowest first and the highest in the end. Now while T is the final spanning tree, okay, we consider it to be null initially 5, and then while T contains less than n-1 edges, because we know the condition for a tree, it should have n-1 edges. So the spanning tree, when it is containing n-1 edges, we will go inside the loop. So choose an edge such that it is of the lowest cost. We have this list sorted, so we take the first element from that. Now you take the first element, you delete that from the list. And then if that particular edge does not create a cycle in the spanning tree that we already have, so you should keep writing the spanning tree, and if that does not create a cycle, because if it creates a cycle it will not be a tree. If that does not create, you just add it to the spanning tree. If it creates a cycle, you just discard it. That's it. That's written here. If that does not create a cycle, add this to the spanning tree, else we can discard that edge and then complete the algorithm. Now going through this example, let us start running this algorithm over here. So this is the initial graph with vertex and edges, which has 5 A, B, C, D, E, which has 5 vertex. So there should be totally 4 edges in the spanning tree. Now this is the edge set that they have given. Let me define the sorted array of this, right? Okay, let me write it here. Edge set sorted will be in this way. Edges sorted will be, this is obviously lesser, so DE, I'm writing it first. Next, if you see 2, so I'll write BD and AB. BD and AB, and then the 3 comes AD, CD. And then CE comes, and then AC comes. There are totally 1, 2, 3, 4, 5, 6, 7 edges. This is sorted in this order. I'll also write the edges in this format. So DE edge belongs to the number 1 weight. So this is EW, I'll write. So 1. BD means it's 2. Again AB is 2. AD is 3, 3, and then CE is 4, and then 5. So this is the sorted way that we are writing. Okay, so now the array is sorted. Let me start writing the spanning tree. While T is empty, so initially tree will be empty. Now T is containing as obviously less than n-1 edges. We have to choose the lowest cost. Now which is the lowest cost here? 1 is the lowest cost. Now we need to delete that edge. I am deleting this edge DE. Okay. Now having the spanning tree with DE. So initially spanning tree means it contains obviously all the vertices by its definition. So I'll just write all the vertices. We'll just keep adding the edges. Now I deleted this. Now I have to check if that does not create a cycle in T. Does not create because there is no edge at all. So this is the first edge that we are going to add. We are going to add this edge called DE with a cost of 1. Okay. Now we have deleted it, and then if it does not create a cycle, yes, it does not create a cycle. We have added it to the spanning tree. Now we go to T again. It contains n-1. N-1 is to be defined here as 4. It contains only 1 edge, right? Now it contains, yes, go and select the next shortest edge. Either you can select this or this according to the order you have. I have put BD, right? So select this and delete it. That's it. Now after deleting, you need to check whether that creates a cycle in the spanning tree or not. BD, does it create a cycle? No. Then you just add it here and then write the cost. Now this is 2, right? Done, completed. Now again go, it does not contain 4 edges or more, it contains less than that because there are only 2 edges. Now again take the lowest cost from this. So which is AB, delete it first and then check for the cycle condition. AB, it does not create a cycle again, so you just add it here. AB, we have added this edge because it does not create a cycle in T. Again, it does not contain n-1 edges, it contains only 3 edges. So one more loop you need to go inside. Consider the lowest cost edge. AD I am considering. So now, if you see, if I put AD edge, it creates a cycle. It creates a loop inside this. DBAD will become a cycle. So now this condition comes, I am discarding this. I am not doing anything with this. Again, I'll pop the next element, which is CD. I am just deleting CD and checking if it creates a cycle in the loop. No, it does not create a cycle. I'll just write this with 3. Now going ahead, 1, 2, 3, 4, there are 4 edges already created, right? So T contains exactly n-1 edges. This condition fails, it comes out of the while loop. This is the final minimum cost spanning tree that we have. So T is defined like this in Kruskal's algorithm. Let us find the cost of this and verify whether we have got the same cost as the earlier one. So cost will be equals to, obviously 2 plus 2 plus 3 plus 1, which is equals to 8. So this is the minimum possible cost of the spanning tree out of all the spanning trees possible out of this particular graph set given. Thank you.